Welcome back to Algebra 2, Chapter 5, Section 2. In this book, we are solving quadratic equations by factoring. So let's review how to factor. Wasn't this your favorite part of Algebra 1? When I took Algebra 1, I had been in a terrible horse accident. My horse, Gypsy, would never have done this to me, but my friend's horse, Buck, he had a new bit in his mouth and he grabbed it between his teeth because it wasn't strong enough, and he jumped a creek with me on his back and then tried to scrape me off like gum off of your shoe by running me under the eave of the barn. Smacked my head on the front, turned around, came back and smacked it again. And had a terrible concussion. Nowadays they would send you home for a year to just veg out and not think. But back then they didn't know. It was the dark ages of concussion medicine. They just packed me off to school and I tried to learn Algebra 1, and I remember thinking, this is the hardest thing ever. And I remember just looking at the other kids, how do you understand this? And I don't. Because I'd always made straight A's before the head smack. It smacked me so hard, it knocked me out, but I saw double for a month. And when you see double, it's not like one is real and one is ghosty. They're both looking real. So I'd have 2 glasses of milk and I'd think, which one's the real one that I poured in? I can't remember. I've got a concussion and I always pick the wrong one and just pour milk on the table. Anyway, if you're not concussed, it's not as hard as I thought it was. I think you'll be able to do it. All right, so how you factor this. What it is remember before I showed you how you could multiply 2 things in parentheses by using the FOIL method, by using the distributive property, and now we're going to go backwards. We have the answer, now we're going to go back to 2 things you multiply together to get it. Alright, so step 1, you draw your parentheses. That was always my favorite step. Step 2, if there's an x here without a coefficient, you just write x at the beginning. That's easy too. Step 3, you look at the bare number, okay? And you write down its factors. Don't worry about the sign. Just write down things that you can multiply to get it. And I want you to do it in an orderly fashion. The first one I want you to do is 1 times that number. Next thing, does 2 go into it? Yes, it does, 14 times. Does 3 go into it? No. Does 4 go into it? Yes, 7 times. Does 5 go into it? No. Does 6 go into it? No. We're back to 7 going around our U, so we know we got them all. Because sometimes there'll be that one you didn't think of. But if you do it organized, like how I just showed you, then you won't get stumped. Okay? So now, what I want to find the 2 of these, the pair of factors that multiply is 28, they all are, but added or subtracted is 12. Don't look at the negative, just can there be 12 between them? 1 plus 28 is 29, 1 minus 28 is 27, neither is 12. I get to mark that one off, okay? 2 plus 14 is 16, but 2 minus 14 is 12. This is a very good candidate. Now, let me just show you that this one doesn't work. 4 plus 7 is 11. 4 minus 7 is 3. The winner is 2 and 14. I write them down. It doesn't matter which one you write it in. Next, you look at the sign of the middle term, and it will be the same sign as the biggest number. 14 is bigger than 2. It gets to be the negative. Then you look at the last term and you say, what sign does this need to be for it to have this sign? Well, if it was negative, 2 negatives would make a positive and it wouldn't be that. So I know this one has to be positive because it's got to be positive 2 times negative 14 equals negative 28. Now, these are considered the factors, and why we like the factors is we can get from the factors to the solutions. Remember, what is considered the answer to this problem is where the U, the parabola U, crosses the x-axis. And it will do it at the opposite sign of these. So it would cross at, I didn't draw it good, negative 2, x equals negative 2, and x equals positive 14. So that would be 14. But drawing is not to scale. All right, so that's how you do these. That wasn't terrible, was it? Nobody got a rash, nobody cried, and nobody ran out of the room screaming. We're doing good. Okay, sometimes they're ugly. They're ugly when an x has a coefficient. So luckily, 3 only has 2 factors. So I know one of these is going to be 3x and the other one is going to be x, because that's all it can be. 3 doesn't have any more factors, so at least it's not too ugly. 10 is 1 and 10 and 2 and 5, and we're done with our u. So now we got to think, well, which way can we put of these to end up where added or subtracted there's 17? Well, if I put 10 here and 1 here, I would get 30 and 1. It could only be 31 or 29, so I know that's wrong. So now I'm going to flip it. Here it would be 1 times 3 and 10 times 1, and 3 and 1, 3 and 10 cannot be 17. So I'm eliminating 10 and 1. I'm going to try 2 and 5. Okay, so if I put 5 here and 2 here, this is 15 and that's 2. And 15 plus 2, ding ding ding, is 17. So I'm going to put a 2 here and a 5 here. Now, it's a little trickier with our signs, but not too bad here, because this is negative, and we know the bigger number, and it's kind of harder to tell, will have the sign of the middle term. But I can see that this is negative and that's positive, so I know this has to be negative because I have to have negative and negative to be a positive. I can't have this negative and that positive without both of these being negative. Now, what is the solutions for this one? Well, this one's easy, x equals 5, but this one is tricky. How it works is what's over here is the numerator. So it's a 2, and this number is the denominator, and it has the opposite sign. So the other one is 2/3 positive, and this one is positive 5, or the solutions where this one would cross. Okay? Now there are certain special patterns. One of them is, which I'm calling them the specials, one of them is the difference between 2 squareds. Do you see how x is x squared? And 9, the square root of it is 3. So if you have subtract between two squares, you end up with a pattern. The x's go here, but we don't need to remember the pattern. We can just know I need something that is multiplied to get 9, but added or subtracted is 0. Do you see how there is no x term? That's because the x term is 0x, so we don't have 1. Well, you can't add 1 and 9 and get 0, but a positive 3 and a negative 3, ding, ding, ding. So we know that this is going to be plus or minus 3. So our u is going to cross at the 3's. It's going to be very symmetrical. Of course, you will put arrowheads on these things and not do crazy little graphs like me. Alright, so my solutions here, x equals, well, I won't do a plus, you don't do that. And this x equals negative 3, and this x equals positive 3, because they're the opposite sign. Alright, sometimes when you factor, so see how I said not? I have found you can always do the specials a different way. And when kids try to memorize the patterns of the specials, they get them wrong and miss the problem. So I would rather you not memorize the specials, but I want you to know they exist. And as you do math, for Algebra 2, and pre-calculus, and college algebra, and college pre-calculus, you're going to start recognizing the specials and going, ooh, difference between 2 squares. But I don't want you to work on memorizing. I want it to come naturally as you do your math. Okay? Let's try this one. Sometimes you have something like this, and there is a number that can divide into both of these, and you pull it out before you do the problem. 5 goes into both 5 and 20, so I'll pull it out here. 5 times x squared is 5x squared, 5 times negative 4 is 20, and you pull this out first before you factor it. So now I need and the 5 will actually go away. So remember how I told you that y and 0 are weirdly the same thing? It's because of this. Y is 0 when something crosses the x-axis, right? So that's why y and 0 is the same thing. So if I tried to move 5 to the other side, it's being multiplied, I would divide both sides by 5. Well, 0 divided by 5 is 0, so that 5 goes away. It's not a solution, it's not a place where that goes, and that's why it's not here. I divided it out and made it go away. So now, what can I multiply to get x squared, x and x? What can I multiply to get 4? 1 and 4 and 2 and 2. But I need the middle term, the x term, to be 0. I can't make 1 and 4 0, but I can make 2 and 2 0. If one's positive and one's negative, the solutions are 2, negative 2. The 5's not in there. Okay? So let's look at this one. We can pull out a 2. 2 goes into both of these. But notice there we have two x's here. I can pull out an x also. And then I'm left with x minus 4. Now this one's a little weird. I was able to make 5 go away. 2x doesn't go away. It's because you say 2x equals 0 and x minus 4 equals 0. So we divide both sides by 2. So one solution is that x equals 0. This one we do plus 4 to both sides, and we get x equals 4. So these are the two solutions of this one. Now, this is called, this is how you use zeros to find solutions. We did this in Algebra 1. You might have forgotten. You might need to review it a little bit. All right, so here's another one. Can't pull anything out, but we're going to factor it. We need things that are multiplied to get 18, added or subtracted is 3. 1 and 18, nope, that's 19 or 17. 2 and 9, nope, that's 11 or 7. 3 and 6, ding, 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 that one wins. Now the bigger one is the sign of the middle term.